Okay, so in this situation, we're no longer in equilibrium, okay? The object is moving down the plane, okay? So hence why I've drawn in an acceleration arrow there to show the direction it's moving in, okay? We're asked to first of all find out what r is, the perpendicular, the normal reaction, yeah, to the inclined plane, and the value of a. Okay, now a is the value of acceleration, okay? So we're given the fact that, okay, so it's moving down the plane. There is sort of like a resistant force here of 50 newtons, okay? But we need to find out then basically what r is and what the acceleration is. Now we're told in the question that the mass of the object is 40 kilograms, which means then the weight would be 40 times g, yeah, the value of gravity, okay? So remember then what we do with these questions, okay? We try to create this cross situation, okay, where the sort of y-axis, if you like, goes like that, okay? So we continue the r there, that line, and make it broken down here, and then the x-axis then will be acting parallel to the plane, okay? And of course, it's much easier to see if you turn your sheet around like that, so you can see then your cross, okay, so your y-axis, your x-axis, okay? So do that. The other thing then is to, well, this force here, okay, we need to get the sort of components in the y direction, the x direction. But to do that, of course, we identify this angle here. This angle here is always the same as that angle, yeah? Okay, easy to see. You know, you've got your triangle here, right angle triangle. That's got to be 70, isn't it? It's got to be 70, 20, and then 90 here. Okay, so if that's 70, this then has got to be 20. So this angle is the same as this angle, always. So if we turn it around then, you can see then what we've got. So we've got 50 newtons resistant force in that direction. Now the weight, of course, goes vertically downwards, which means we've got a component going across in the x direction, across the corridor, yeah, and then down the stairs then in the y direction, okay? So because you've got the angle 20 here on this side contains that angle, so it's going to be cos on this side, so 40g cos 20, and then the other way down will be 40g sine 20, okay? So even though there's a force here, okay, resisting it, stopping it from sliding down the hill, it still slides down. It still slides down, and the reason why is because of its weight, okay, and the weight component here is strong enough to overcome that resistance there, okay. So first of all, we'll resolve, okay. Well, they ask us to find r and a, so let's find r first because that's the easiest. Of course, when we find r, okay, we need to resolve perpendicular to the plane, okay. So rather than writing all those words out, resolve perpendicular to the plane, what I might be tempted to do is just to draw a little sketch to show the direction I'm resolving in, okay. So perpendicular to the plane there, in that direction. And if you then sort of turn it around, as I said again, to look at that cross, you can see then you've got r going in positive y direction, and 40g cos 20 going in the negative y direction. Now, in the y direction, we've actually got a balance, we've got an equilibrium, because if we think about it, in the y direction, there's no movement, okay? So if you think about this now as like the flat, okay, that particle there stays on the flat, doesn't it? It doesn't sort of rise from the flat, it doesn't bounce up, or it doesn't go through the flat, doesn't it? It doesn't dig into the road, it stays level on the road, which means then in the y direction there's no movement, absolutely no movement in the y direction. So basically what goes up equals down, okay? So the reaction here, okay, matches the weight component. They'll be equal, okay? So it's in equilibrium. So we can literally say r, okay, is equal to 40g cos 20, okay? So calculate the time, 40 times 9.8 times cos 20, and that will give me my r value, okay? So if I do that, I get 368.36 newtons, okay? That's the value of r there. Now, to get the value of acceleration, I now need to resolve parallel to the plane, right? And if you appreciate then that essentially we've got movement, okay? So parallel to the plane will be going this direction, yeah? Okay, so because we've got movement, we've got acceleration, of course we think about Newton's second law, okay? Applying Newton's second law of motion in direction of motion, okay? Well, remember now the resultant force equals to mass times acceleration, yeah? That's Newton's second law. Now think about the resultant force. You've got in this direction here, well this is the bigger force, isn't it? This is the bigger force here, and this is the resistance, so it'll be the resultant force will be 40g sine 20, take away the resistance which is 50, equals then to the mass which is 40 kilograms, remember, so 40 times A. So it's a simple case then of working this out. So 40 times g, which is 9.8, times sine 20, take away 50 equals 40 times A. So I'll work out the left hand side of my calculator. And that comes to 84.0718, etc. And that'll be 40A. And then of course to get A then I need to divide by the 40. So 84.0718 divide by 40. So on my calculator, ants divide by 40, and I get 2.10 meters per second squared. Okay, so this is a case of applying Newton's second law using resultant force equals mass times acceleration, because we do have acceleration parallel to the plane. Okay, but perpendicular to the plane, there's no change, there's no movement, it's always in contact with the road. So we can say they balance there, okay?